Before starting this video, let me tell you, if you have any doubt regarding this problem or any problem, you can contact me on Instagram, or even you can join my Discord server. I will provide both the links in the comment section. I will pin it. So in this video, I'm going to discuss the GFG weekly today's problem, which occurred good tree, which was the last problem, which was of 40 marks, I guess. So it states that you're given n, that is the number of nodes in a tree, and an array par, which is the array form of the tree. Okay, so we know that. Let's convert this into the tree, as the array form states that 1, this is 1, then 1, that is parent of 2 is 1, so this is 2, and parent of 3 is 2, this is 3, parent of 4 is 2, this is 4, and parent of 5 is 4. So you have to find the number of operations that you have to perform so that this becomes a good tree. Okay, so good tree is something in which the number of inner nodes is greater than the number of leaf nodes. That is, in this case, the number of inner nodes are 1, 2, 3, and leaf nodes are 2. So 3 is already greater than 2. So we are going to return 0 because we don't need to perform any operations. So in this case, this is 1 and 2 is the child of 1. This is 2. Now this is internal nodes is 1 and leaf node is 1. That is, both are equal, but this is not greater than 1. Okay, 1 is not greater than 1. 1 is equal to 1. So we have to now perform the operation. So what the operation states? It states that you can take out any node and any subtree or any node and fix it into some other subtree, or to fix it into any other node of a subtree. Okay, so that's how you're going to do it. Let's say, so in this case, if I take out 2, okay, if I take out 2 and you have to add it to any other node, there is only one node, that is 1. So this is the problem for this case. So there is no possible way, so we return -1. So let's say there was a tree like this. Okay, there was a tree like this. Now the number of leaf nodes are 1, 2, 3, 4, and internal nodes are 2. Okay, internal node is 2 and leaf node is 4. Now 2 is greater than 4, obviously no. So what we are going to do, the simple logic behind this is, you're going to take out any one of the node, any one of the leaf node. Okay, so let's take out this one and join it to any other leaf node, that is this. So now what is the number of inner nodes? 1, 2, 3, and external, that is leaf nodes, are 1, 2, 3. So still it is not being satisfied. So now we have to again take a leaf node, that is, we are going to take this one and join it to another leaf node, that is, let's say this one. Okay, you can even join it to this one, doesn't matter. So now how many internal nodes are there? 1, 2, 3, 4. So now inner is 4 and out, that is leaf, are 2. So now 4 greater than 2. So we have to perform 2 operations on this. Okay, for this case you have to perform 2 operations. I hope now the question is clear. So now let's go into directly into the pseudocode. The pseudocode portion. Okay, so in is equal to 0, out equals to 0. Then you can use a hash map, that is, you know the format of the hash map, and then run a loop from 1 to n, that is this array excluding the first element. Okay, excluding the first element, run the nodes, and if the map does not contain the key, the element, that is par of I, then in plus plus, and then we have to put this par I into the map. Okay, so now one thing about this thing is, if you notice this very clearly, in this case, what are the internal nodes? 1, 2, and 4. And if you check this pair, this is the parent array, then what are the nodes that are except -1 present in this? That is 1, 2, and 4. So this is basically the internal nodes. Okay, so this is what I am doing to find out the number of internal nodes. And external, that is a leaf nodes, is equals to n minus n, that is the total number of nodes minus the number of internal nodes. Now there are cases. Okay, case 1, if internal nodes is greater than leaf nodes, which is the condition of a good tree. So we are going to return 0 because we don't need to perform any operation. If internal nodes and leaf nodes are equal and internal nodes is equal to 1, we have to return -1. This is the case 2, that is this case, which is a very exceptional case. Okay, this is an exceptional case. And if the both are equal, then we have to return 1, because if internal, that is, yeah, that the internal nodes are not equal to 1 but the number of internal nodes and leaf nodes are same, then we have to just perform one operation, that is take one leaf node and put it into another leaf node, and we are done with it. So this is the case 3. Okay, now the case 4, that is the final case, where this is the most important case. Okay, that is, we have to return that if none of this satisfies, then we have to return b minus a plus 2 by 2. Now what is b? B is out, that is leaf, and a is in. Okay, so let's rewrite this as out minus in plus 2. So in this case, let me write it again. This was the tree, and this answer should be 2 according to the steps that I have told you. So the number of internal nodes are in is 1 2 and out is 1 2 3 4, that is leaf nodes. Now let's see, out minus in, that is 4 minus 2, 2 plus 2 by 2, that is 4 by 2 is 2. Now no matter whatever tree you take, this is the basic formula for this. Okay, this is the basic formula for this. So this is basically the pseudocode for this. Remember one thing, by in I meant leaf nodes, and I'm sorry, by out I meant leaf nodes, and by in I meant internal nodes. Okay, so this is a basic pseudocode. Thank you. This was a tough one. If you like, even I couldn't solve it without the hint. So this was a tough one. Thank you.